Hi everyone. So I'm really excited to be here today. As we said, introduction to chaos engineering. So you can find me actually on Twitter at Tammy Butow. And yeah, thank you so much for having me here today, and thanks for coming along. So today we'll do an introduction to chaos engineering, then I'll leave some time for Q&A, and then thank you at the end. Yeah, as I said, you can find me on Twitter. I'm a site reliability engineer. So I guess, does anyone know what a site reliability engineer might do? It's always a good place to start. Yeah?
Keep sites up and test resilience.
Yeah.
Inject failure and make sure that it keeps stable.
Yep, perfect answer. So keep sites up, make sure that things are resilient, inject failure to make sure that systems stay up and running, do experiments, that type of thing. So yeah, I look after a lot of different things, but generally the whole idea is you care a lot about uptime and you also care about data loss. So you never want to lose data and you want to make sure that you have everything up and running as much as you possibly can. But we'll go into much more detail too. So I work remotely from Australia right now. Our head office is in Silicon Valley. And I have a website too, Tammy Butow, and if you go to tammybutow.com/speaking, you can see a lot of talks that I've done in the past, which I've actually shared a lot of things that we did at Dropbox and also at NAB and some other places. So yeah, there's some good stuff up there. So these are the places that I've worked in the past. National Australia Bank, I was actually there for almost 6 years in the technology team. DigitalOcean, anyone heard of DigitalOcean? Yep, a few people. So it's cloud infrastructure, similar to AWS. And I worked there straight after I left NAB, and that was really cool. It was based in New York. And then I worked at Dropbox for 2 years as a site reliability engineering manager, where I led the databases team and another team called Magic Pocket, which is block storage. So basically all of the files and data that anybody stores on Dropbox, that was my responsibility to make sure we never lost it, and then it was also highly available. And way many years ago, while I was actually studying at university, I worked at QUT while I was there, so that was quite good. And I was actually based inside the university data center, and it was a really good way to learn about infrastructure because it was quite small. We didn't have that many servers, but it was a good place to start. And you also have very demanding customers, professors. And yeah, everything has to be running really well for them, and they do a lot of research, so it was quite interesting. And now I'm at Gremlin, which is the little Gremlin logo there. As we mentioned too, I worked at GirlGeekAcademy. So this is actually something I founded with a few friends a few years ago. So about over 4 years ago now, we founded GirlGeekAcademy. And I'll show you the reason why. So we just had this idea that when we'd go to hackathons or we'd go to events about technology, go to meetups, there were never that many women there. Often I would be one of the only women. And then I started to meet a few other women that were interested. But we just thought it'd be great to have more women to come along. So then we founded this academy, and we thought we're going to not only help make sure that there are more women coming along to these events, but we also want to help women learn technical skills. So yeah, that's what we did, and it's been really successful over the years. We even raised $1.3 million, which was really cool, from the Australian government and the Victorian government combined. And we have online courses that people can do. We run hackathons around the world. One is called She Hacks, which is just about building an application in 3 days. Anyone ever been to a hackathon? Cool. Yeah, so yeah, hackathons are pretty big right now. And I think I've been going to hackathons since 2009, so almost 10 years now. And I always found them to be really valuable, and I learned a lot, especially because if you say go to a hackathon at Google, then there are Google engineers there and they teach you so much in a weekend. And that was one of the reasons that I was inspired to also go and live in America for a while, to learn more from those people there. So over the years, I've had a lot of different work experiences building tools, infrastructure engineering, automation, incident response, incident management, observability and monitoring, hardware engineering. It's a little bit of a niche skill these days. Game days, disaster recovery testing, team leadership, and security and product engineering. So I've led teams of up to 33 engineers. And I've also worked across the world now. So Sydney, Brisbane, Melbourne, New York, San Francisco. Now I'm remote. So chaos engineering, and what does Gremlin do? So the whole idea behind Gremlin is that nobody had created a company that was focused on doing chaos engineering and actually building that chaos engineering as a service, or you could call it resilience as a service, failure as a service, and we really wanted to help people do that. So the whole idea behind what we do is we help you break things on purpose. And that's because downtime is really expensive. If your system, sometimes systems can be down for a long time. 3 days, 4 days. Like that's, some of the cases that are actually pretty common. And it's really bad because then your customers can't access it. They worry about what's going on. I know that when Facebook is down, people actually call the police. So yeah, things like that. It's actually pretty serious. So we have created this company. We only just launched in December. And the people that launched the company, so they're two friends of mine, and I was really excited when they created the company, and they talked to me about joining a few years ago actually when they were just starting to kick things off and build something to get seed funding. Now we've got Series A funding, which is really good. But basically they did chaos engineering at Amazon, and they also did it at Netflix, and they did it at Salesforce. So the founders have had a lot of experience doing chaos engineering for over 10 years, which is a very long time, even though it's actually quite new. So this is our CEO, Colton. He was a chaos engineer at Netflix, and he designed and built Fit, which is something that's still commonly used at Netflix. It's a failure injection service. And prior to that, he improved the performance and reliability of the Amazon retail website. And also at both companies, he was a call leader. So a call leader is someone who is responsible for any type of incident that occurs, especially high severity incidents. And I did this when I was at Dropbox too. So basically I would be on call 24/7, once every 4 or 5 weeks, because you have a rather small call leader rotation. And then you would get paged if anything broke. So when you're in that role, you have to have very good understanding of all of the different services, who are the different people that own the services, what are the downstream impacts, the upstream impacts, and who are the people that you might need to get online really quickly that would be a good technical leader on call for that specific incident. And you have to be super calm under pressure. That's like always one of my strengths. And you just have to try and figure out how can you work as a team to get stuff fixed. And my goal is always to really fix things as fast as possible. And through that, you have to just put in mitigation very, very quickly. And you have to have very good detection as well. That's a big part of it. But I actually recently wrote a blog post, which is called How to Establish High Severity Incident Management Program. And you can read that if you're interested in learning more about that side of the world. So this is our CTO, Forney. And Forney did chaos engineering at Salesforce. And he also worked at Amazon as well, where he founded the Fatals team to analyze and fix customer-facing failures, reduce the number of retail website errors by half in his first year, which is pretty cool. So I think that's a great team to start this company. So what is chaos engineering? So it's an emerging discipline still. There's been a few people that have been doing it, but it's still one of those things that people are just starting to do right now. And the whole idea there is failure is going to happen. Are you ready for it? So you really want to be prepared because you know that things are going to break. You're going to have problems with firmware. You're going to have problems with kernels. You're going to have problems with hardware. You're going to have problems with so many different things, bugs, new people that are just training up and maybe they did the wrong thing because their training wasn't good enough. So it could be things like that. So the whole idea, stuff's going to break. Are you ready? And we say that the best way to figure out if you're ready is to actually break things on purpose during normal hours when your whole team's there to actually look and see what happens when you actually inject that failure. So it's better to break something on purpose at 10 a.m. or 11 a.m. instead of something breaking at 3 a.m. when everyone then has to get paged and woken up and try and quickly run to their computer and fix things, which is quite tough. And a lot of people have tried to do things to make it easier when things break at 3 a.m. So you might have heard like the idea of follow the sun on call, where you would have a team in, say, the US and also in Europe. But that's quite hard because then you have to have a team in both places. And if you're only located in one area, then it's really tough. So it doesn't work for everybody. So the idea behind chaos engineering too is that it should be controlled. So we don't really like the idea of injecting random failures. Sometimes this is what people would say is a good idea, but we don't really think that that's a great idea. You could do it, like you could randomly shut off a service or randomly turn off a host, but really it's not going to teach you as much. Maybe that's a good thing to do after you feel like you're really confident and you're very good at being able to handle failure. Then you could do the random shutdowns. Because if you do a random shutdown, it means that not even you know who's going to be affected. Not even you know which service will be affected. And then you have to make sure that that service is ready to handle it. That can be quite tough. So the idea that we really want to share is all complex systems will fail eventually, especially with distributed systems, containers, that side of the world. This is very popular right now, microservices. Things are going to fail. I'm not sure if anyone remembers there was a huge AWS outage, and I was actually on call for that outage. It was not that long ago. So I was on call for all of Dropbox, and I just had to be sitting at my computer. I was just madly typing away, making sure that everything could be up and running and everything was all right. And we actually had to do some emergency fixes during that outage, but it went for 5 hours. So I was really like not able to leave my computer for 5 hours because I was trying to fix everything, make sure everything was okay. And we actually had about 30 engineers working on the internet at the same time, which isn't very good either, because obviously everyone's got their projects that they need to do and all the other things that you need to do. And then when you have a big issue like that and you don't have the steps in place to be able to mitigate it, then it can be quite tough for your whole team. So by simulating potential errors in advance, we're able to verify that our systems behave as we expect them to. And there are a lot of fixes that you can put in place. But the thing there is like, you might know, I know how to mitigate against that fix, but do you have the time to put those measures in place? That's the big thing. So I think the great thing about chaos engineering is that it actually makes you have the time. So you actually set aside the time. You might do something like a game day where you all get together, like 10 to 15 people in a room, simulate, you actually cause some failures, and then you run through and make sure that everything's okay. You check your monitoring, you check your dashboards, make sure that everything's great, and then you set up some action plans of what you're going to do to fix it. So a big word of caution, you should never conduct a chaos experiment in production if you know that it's going to cause severe damage. Sounds like common sense, but that's like the biggest thing. And I've definitely seen chaos engineering experiments cause outages. And if a chaos engineering experiment causes a big outage that impacts customers, then you have to do a post-mortem just like you would usually do. So that's a really important thing to remember. Just because it's chaos engineering doesn't mean you get to get away with all the other things. If you cause an outage, then that's something that you have to deal with too. So I thought I would show you this great diagram that was created. So somebody created a diagram here which is a handy way to be able to see the history of chaos engineering. Does anyone know some of the things that are commonly talked about when we talk about chaos engineering? Anyone got any systems or teams or? No? No?
Oh, we're talking about like Chaos Monkey?
Yeah, yep, exactly. So Chaos Monkey is a pretty well-known one. That's from Netflix. But there's a ton. So let's look. And I'm using Windows for the first time in ages. So bear with me. I mostly use Linux and Mac. Okay, so you can see over here, I'll just start where I am because that's easy. So while I was at Dropbox, this is me here, Tammy Butow, when I was the engineering manager there. And I also work with Tom Issa. We did a talk at QCon which was all about disaster recovery testing and how you can use that. So do you do disaster recovery testing here at Geoscience Australia? A little bit? Yeah, a little bit. Yeah, like often that's actually a great place to start to think about doing chaos engineering. So like when you do disaster recovery testing, you might say, let's shut down, like this is how we do it at NAB. We would say, let's shut down this entire data center and fail over to our backup data center. That's a pretty good thing to do. And you have to do that when you're at a bank because you need to be able to keep your banking license. If you don't have a banking license, then you can't be a bank. And yeah, you have to do the disaster recovery testing. So I learned a lot through doing those. We used to have to do them all the time, once every quarter. And actually, I thought it was quite fun and an interesting experience. We actually had to go to this secret data center that you're not allowed to say where it is. And you would go there, it's unmarked, and we would be there for the whole weekend. But we got to have pizza, and I was like very excited by that. And I was pretty young too, so I was like, yeah, I'm working on the weekend and like breaking things on purpose and making sure that everything works well. And it was a really good experience. I learned a lot. But then the idea behind that, it's a good start, but it doesn't really help you test all the time. It's not very frequent. You need to move everybody to an entire different location, make sure that everyone's in the room. You need to then like run through these huge tests. They have a lot of checklists that they check off. So it's like a very long process. And they test every single service instead of thinking, what are the key critical services that I want to test? And that's the idea behind chaos engineering. It's better to actually pick the key critical services to focus on first. So yeah, I learned a lot from that, came to Dropbox and started to do a lot of disaster recovery tests at Dropbox too, but we do them once a week. And we would focus on our key services, databases or Magic Pocket. So then you can see, if we scroll up here, here's Colton and Fawny and also Matt Jacobs. He's on our team at Gremlin. So he's also an engineer from Netflix. And this is Gremlin that was created. It's the first product that you can actually use to do chaos engineering that has a proper team and company built around it. And obviously that's pretty important because you're injecting failure. You need to do it properly. You need to be quite careful when you roll it out. But there are a few other tools as well. There's an open source toolkit that just got created called Chaos Toolkit, which is created by Russ and Sylvan. And then if you go over to the side, it's actually interesting. There's a few other places that I worked at that also do chaos engineering. DigitalOcean's there. So there's a guy over here, Matthew Campbell. He built Chaos Gopher if you use Go, the programming language. So he did that. Also, Bruce Wong worked at Netflix and then he went to Twilio and he created a chaos engineering team at Twilio. They do SMS and phone calls. They have an API for that. It's pretty big and popular in America. And if you scroll down here, you'll see a ton of other ones. So at Uber, they have UDestroy. That's quite popular there. Yahoo has a few, Nemesis. And there's always key people behind these tools. LinkedIn has WaterBear, which is quite popular and it's still used right now. And down here, we have a lot of the tools for Netflix. Chaos Monkey was one. There's also something called Chaos Kong. So lots of tools. You can see there's even more people over here. This is a lot of the Netflix team right here, if you can see them. We have Nora Jones, who is at Netflix now. She was at Jet before that, where she did chaos engineering. And also Aaron is from Netflix. And I know a lot of these people personally because it's quite a small community. So it's really great to learn from each other. And everybody's doing slightly different things, but you can still share what you've learned. And there are also some resources. So there's actually a free book now. So there's a free ebook that you can get from O'Reilly. And there's also a web page called Principles of Chaos Engineering, which was created by Netflix. And that's quite a good little page to read. And that's probably the main things that I think are good to check out. But a lot of people, I guess, would be familiar with Chaos Monkey. And the idea there is you randomly shut down a host and make sure that everything runs. And Netflix would do that all the time because they were using AWS. So I thought I'd also tell you the history in Australia. So one of the things that I thought was pretty cool was at NAB, we actually used Chaos Monkey while I was there. So back in 2014, the press even talked about it. And I thought the headlines were really funny. NAB deploys Chaos Monkey to kill servers 24/7. Engineers allowed full night's sleep. Just thought it was really funny. The article's actually pretty funny if you want to look it up. But yeah, we were really excited about this. So I was there when NAB started to use AWS. We thought let's try and move to the cloud. It was quite hard to maintain a lot of different data centers that we had. And we thought we could probably use AWS for some of the front-facing pieces of the website. So when you go to nab.com.au and it's not user data, it's just some more marketing material or things like that, we could have those on AWS and it would be fine. And that was all approved through security. I actually was involved in doing some of the pen testing for AWS, and it was a very good experience to actually move from our own bare metal to the cloud. So what's the state of chaos engineering right now? This article was actually just recently written. It went up on TechCrunch just yesterday. So that's a really good one to read. You can hear about the rise of chaos engineering over the years. And this was part of the article. But yeah, actually this article featured our founder, Colton. And the author talked about how Gremlin has been created. It's a new startup and we're building chaos engineering as a service. And the methodology of chaos engineering is simple in concept but very hard in execution. And it's so true, because if you cause a failure and you're not sure what's going to happen, then that can be really tough because you're not sure what to look for. And you also need to make sure that your monitoring is set up really well in advance. And that's actually what we specialize in, making sure that that's all good to go before you do the chaos engineering. And one of the coolest things I think is we've built this chaos engineering community all over the world. We have nearly 2,000 members, which is pretty cool. And there's 19 groups now in 10 countries. I've actually created one so far in Melbourne and one in Sydney, and we're sponsoring those meetups. So yeah, people can go along and meet other people that are doing chaos engineering, and that's been really fun. I've met a lot of people through that. And there's also a chaos engineering Slack community which you can join. There's over 300 people in there. So if you want to just ask questions or read what other people are doing, you can hop in that Slack group, and that's also free. And you just go to gremlin.com/community and you'll be able to meet other people from all over the world. There's a lot of great people in there. So often people ask me which service teams should start doing chaos engineering. And I think my recommendations for choosing, it's actually really tough to choose. Often people go, let's just do it everywhere. That's not a great idea. Like, it's great because you have enthusiasm, but it's not great because it can be dangerous. So my top 3 recommendations are: pick tier 0 critical services. That might sound strange because you might think it's better or easier to pick something that's not super important, but actually, like, services that aren't very critical, usually they actually will have a lot more work to do. So they might have not great monitoring, they won't have a huge team around them, they won't have as great knowledge being shared with the rest of the organization. It's actually better to pick your most important systems. So if you actually sit down and say, what are our top 5 most critical systems? That's a great question to ask yourselves as a team. And once you know that, then you can start to do the chaos engineering on those systems. The other thing is to think of which are your services which serve critical functions. So I know that you have a bushfire warning system. Like, that's extremely critical, and that sounds like a great system to actually do chaos engineering on. And the other question to ask would be, do I have any systems that store critical data? So do you have like big data systems? What happens if you lost that data? What would go wrong? Like, that's always a scary thing to think through, but it's really important to think about as well. And one of the stories I love to share is that at Dropbox, because we care so much about never losing data, we actually have many, many sets of the backups. So just to explain that, and often people will say, oh, but it costs so much money, but usually it's like worth it, you know, because backups, they cost a bit of money, but not so much. It'd be worse if you lost the data. So we would actually have a primary with 2 replicas for MySQL to store the data. Then we would also have another pseudo primary with 2 more replicas. So that's already 6 sets right there. And then we would have 2 sets of backups for each. So that's pretty awesome. And we would store 1 backup on site with HDFS, and then we'd also store another set of backups on S3. And then we would do chaos engineering on the databases to make sure that, yeah, if 1 replica fails, that's fine. If 1 primary fails, that's also fine. If, you know, a few replicas fail, that's fine too. Like, you think through what are the different types of chaos engineering experiments you want to conduct, and then you run those. So what are the prerequisites for chaos engineering? I think often everyone would think through this too. You know, what do I need to have in place before I can get started? My top 3 must-haves are, it's really important to have high severity incident management. I have a program for that, including SEV levels and definitions. Do you have that here? No, not yet. So yeah, that's a really great thing to start with. And the idea there is that you could say, okay, like, this is how it would run through. Let's say that the bushfire warning system is down right now, and it's completely down, and it wouldn't be able to trigger if some sort of problem happened. Then you would call that a SEV 0, because that's the most critical type of incident that could occur. And then what would happen is you would automatically page people to let them know that this SEV 0 has occurred. And what we also recommend doing is actually generating a name for that SEV. And, you know, we try to make it not too serious because, like, SEVs are very serious already. So we would try and call them something like cheeky kangaroo, something like that. It actually is quite funny, but then it makes it easier because when you have the SEV occur, you can refer back to that name. And then if it happens again, you can say, oh, look, another cheeky kangaroo just happened and we had one just last week. Like, that's not good. Or we've had 5 cheeky kangaroos in the last month. That's really bad. And it makes it easier because often when people create incidents, they'll call them by their timestamp or what happened. It's just much harder to remember. So having a high severity incident management program, it helps you be able to detect problems, to fix them faster, to make sure they don't happen again. You'll start to measure things like time between failure, and you'll get really good at it. It's very big in America. They use a lot of metrics. So they would often talk about MTTR, mean time to recovery. That's probably the most common one, and it's very well used at Google, Dropbox, Facebook, all of these places, Twitter, pretty much everyone does it. So yeah, it's a great thing to start doing. The other thing is availability monitoring. And a lot of people don't have this, so don't feel bad if you don't have it, but it's good to try and get it. And that would be a high-level health dashboard for www, API, or any of your critical services. And so the reason that that's important is anybody across your whole team, from any team that they're in, they should be able to go and look at that dashboard and be able to say, yeah, this is how we're doing right now. We're at, 100%, everything's fine, or no, like we're actually having an incident right now. It looks like it's a SEV 0, or it looks like it's a SEV 1. And that's a really important thing to have there, because if you don't know where to look to see how healthy everything is, then that's a problem. Because you just don't have the insight. And anyone should be able to have access to that at any time. The other thing is alerting in pages that call a human and wake them up for those big sevs. So often people use PagerDuty, and you would have a Sev 0 or a Sev 1 automatically page somebody, wake them up, and then they would go and fix that issue. Those are really important too. So I was going to do like an actual live demo, but what I think, because I have like Windows and I got Linux and it's all a little bit of it's a bit hard, so I'll just go through and explain to you what I would have done and share it with you. So you can build a very good demo quite easily to be able to try out chaos engineering. I think that's a good way to start. Instead of doing it on your critical services, it's good to just play around with the tools first, build a test environment and try it out. So what I built was a droplet from DigitalOcean for your cloud infrastructure, Docker for containers. I have an app that we can use, then also Gremlin for chaos engineering, Datadog for monitoring. So I have DigitalOcean droplet. You could use AWS, Azure, whatever. Docker, do you use containers here or not yet? Yeah, yeah, cool. Yeah, so it could be Kubernetes, Docker, something like that. The demo app I had was just a voting app, Cats First Dogs. You can actually get this demo app off Docker if you search for voting app, but I'll send the slides after this. So this is a nice little demo application that has a few containers, and you can then cause chaos on it. So this is what Gremlin looks like. It's really nice because it has a very simple UI to do chaos engineering. Whereas before, I guess, like a lot of the tools that existed were open source. You would start them up and just have command line interface where you'd say, shut down this server. But we're trying to do it in an easier to use way, I guess. So the first thing you would do is say, let's create an attack. And then you click that. If you want to see what attacks are active, you click on active attacks. You can schedule attacks. So you could say, I want to do this same attack every single Tuesday and make sure that everything's okay. That's a good thing to do. You can actually see reports. So you can look and see what are the attacks that we've run in the last month. What kind of attacks were they? Did they fail? Were they successful? And then you can install your Gremlins, which is really easy. It's just an agent that sits on your host. So this is what Datadog would look like if we spun up that demo application. And you can see here, if you're using, so Datadog's just a monitoring tool. It could be New Relic or something like that as well. But I like this one. It's pretty easy to use. And you can see here we have a number of different containers. There's the agent, which is the Datadog agent. It's in a container. I put it in there. There's a voting app worker. There's the results. There's also the vote. And then there's Redis and a database. So those are our containers there. And you can see we're monitoring a few things like CPU. So then when we actually perform chaos. So if I then went and tried to cause a CPU attack, this is what it might look like. So you can actually use the command line interface for Gremlin too. So if you type Gremlin attack help type, you'll see all the different types of attacks that you can cause. And we have black hole, CPU, I/O, latency, memory, packet loss, shutdown, DNS, time travel, disk, and process killer. So that's the ones that we have right now. We just launched in December, so lots more coming. But yeah, that's pretty cool, a lot that you can do. And then what I might do then is actually say, okay, I'm going to spin up a container that's going to attack a different container, and I'm going to cause a CPU attack on that container. So this is me here just saying run Docker. I have my org ID and my org secret just so that I can use Gremlin. And then you have to have Docker sock as well for it to be able to have the permissions. And then I'll just run attack container. And I previously got the container ID from running Docker ps-a. And then I can see, all right, I'm going to attack one of the worker container. And then if you actually hop into a container that's being attacked, so that's something you might like to do, you can use something like ATOP to see the attack in progress. And I think ATOP's quite nice for this type of thing because if you use top, it doesn't have as much detail, but ATOP's nice because you can see it goes red there. That's over there on the left, the attack. So yeah, it actually happened. And then you can see here too, when I span up that container, it's a sidecar, and it's Gremlin-466, and you can see there the CPU rising, and that's me attacking the container. That's how it shows up in Datadog. So how can you learn more about chaos engineering? Like I said before, we've got a Slack community. We are on Twitter as well, trying to share some tips and articles at Gremlin Inc. There are technical papers that you can read as well, like the one I said about how to start an incident management program. You can go to conferences. There's a lot of videos if you can't get to the US. Like I remember when I was living in Australia, it's so hard to get to the US. It's very expensive and it's tough to go there for just a conference. The conferences also are quite expensive. So actually the great thing is many of these talks are online and you can watch them for free. All of the QCon talks are for free online. All of the SRECon talks are for free online. Velocity, you need to have a membership with Safari. But yeah, it's pretty cool that there's a lot of resources out there you can watch today if you wanted to. And then there are also chaos engineers that you could follow on Twitter, Colton Andrus and Call Me Fawny. Yeah. Well, thanks so much for having me come along. Yeah, you're looking after really important systems for everyone in Australia. So it's really great that you're here doing this work, and hopefully that was helpful and you learned some new things about chaos engineering and also incident management. But yeah, please feel free to jump on our Slack community and read through our papers that we have. We'll have lots more that we're going to share in the future too. Thank you.